All right, so let's go through some of them. Start with this 2 that's on the outside. Okay, so that 2, is that inside or outside? Outside. It's affecting the output. It's outside. So that means it's vertical. Okay, so this is a vertical change. It's multiplication, which means it is stretch or a shrink as opposed to a shift. Okay? It's a vertical stretch or a shrink. Okay? I'm multiplying by a big number, right? 2. So, and it's vertical. Is it going to be a stretch or a shrink? Stretch, because vertical is always what you expect. Okay? So this is a vertical stretch by a factor of 2. So all the y values stretched by a factor of 2. So this one, check. That one happens. All right, now let's look at the 1/4 on the inside. Oh, I just told you. Is that inside or outside? Inside, right? So an inside change, a change to the input, is a vertical or horizontal? Horizontal. So I have a horizontal change. That 1/4 is being multiplied by the input. So it's either going to be a stretch or a shrink, right? Multiplication is a stretch or a shrink. So I have a horizontal stretch or a shrink, which stretch, right? Because it's the opposite of what you would think. Multiplying by a small number, you would think would make it small, but because it's inside, it does the opposite, it makes it bigger. So this is a horizontal stretch, which means I'm going to multiply all my x values by something. All of the x values are going to get stretched by a factor of what? 4, the reciprocal of 1/4. Good. All right, then let's look at this this -3 on the inside. I did it again. That -3, is it affecting the input or the output? Input. It's inside the parentheses. It's affecting the input, which means we have a horizontal change on our hands. It's subtraction, which means it is a shift. So I have a horizontal shift. Which way am I going to go? Right 3, because horizontal things do the opposite of what you expect. So this is a horizontal shift, right 3 units. And that means I'm going to move all of my x values right 3 units instead of fight. Yeah. Okay. And then the +4, inside or outside? It's outside. So that means it's going to be a vertical change. And it's addition, right? It's just +4, which means it's going to be a shift. And am I going to go up or down? Up, because it's a vertical, does exactly what you expect. So all of the y values get moved up 4 units. And everything else doesn't happen. What do you think? Okay. Yes. Yep. Yep. Inside parentheses make horizontal change, that is changes to x values. Yep. Outside changes change the output, which is changes to y values. Okay, so I've got another thing here for you to do. This one is actually in your packet. 2 times f of 1/2 x minus 2 plus 2. No, it's find the page. The top of the page says in both of our uh-oh cases, and it's it's page 55. Page 55. So I want you to work in your groups. I've given you the original graph. We now know how to express the transformations using English, right? Now I want you to actually do them. Draw the graph. So just make sure you do stretches and shrinks before you do shifts, and you'll be good. Okay. So We just have to make sure we do stretches and shrinks before shifts. So I tend to just work left to right because you get vertical stretch, shrink, horizontal stretch, shrink, horizontal shift, vertical shift. So the shifts naturally left to right. Sorry, the stretches and shrinks come first, just reading left to right. So it's kind of how I usually do it. So step one, this 2, way out front here, what does that tell me to do? What transformation happens? Vertical stretch, factor of 2. Right. So to create a vertical stretch by a factor of 2, vertical, right, means change the y values, times 2 means double them, right? Factor of 2 means times 2. So I'm going to take every y value in my original graph and double it. So I'm just going to look at a few key points and double the y values because this is just a line, two lines. So this point is -4, 2. It's going to become -4, 4. Just double the y value. This point here, the y-intercept is 0, 2. It's going to become 0, 4. And then this final point, the right end point, is 4, -2. When I double the y-coordinate, it's going to become 4, -4. So there's my vertical stretch. And then moving on to the 1/2. Inside, what kind of transformation does that correspond to? Horizontal stretch, what's my factor? Horizontal stretch, again, times 2. Okay. So it's horizontal because it's affecting the input. It's on the inside of the parentheses. And it's either a stretch or a shrink because it's multiplication. And I know it's a stretch because that number is small. And when you're inside the parentheses, you kind of get the opposite of what you expect. So it's a stretch. Factor is the reciprocal of 1/2, which is 2. So what I'm going to do to create a horizontal stretch, you take every x value and double it. Right? A horizontal stretch change, any horizontal change is going to change x values. To stretch by a factor of 2, double the x values. So from the previous step, look at our 3 important points here and double all the x values. So -4, 4 becomes -8, 4. 0, 4, what does that become? It stays 0, 4 because when you double 0, you get 0 again. So this stays at 0, 4. And then this point at 4, -4, it becomes 8, -4. So I've done both of my shape changes. I did a vertical stretch and a horizontal stretch. Moving on to my shifts. This one inside tells me to shift how? Right 2. So I need to shift right 2 units. Okay, so to go right 2 units, I pick every x value and add 2 to it. So this point at -8, 4, it becomes -6, 4. Right? To go right 2 units, you just add 2 to the x coordinates. This point at 0, 4 becomes 2, 4. And the point at 8, -4 becomes 10, -4. And then finally, my last step, the +2, that's a shift up 2 units. So for my previous graph, I want to shift up 2 units, so I'm going to add 2 to all my y values, or just the important ones. Right? So instead of -6, 4, I get -6, 6. Instead of 2, 4, I get 2, 6. And instead of 10, -4, I get 10, -2. And there's my final graph. This is the function y equals 2 times f of 1/2 x minus 2 plus 2. So you just do each transformation one at a time. Only rule is that you have to change shape before you shift. If we wanted to check a point, let's check, let's say when x is 2, y is supposed to be 6, right, in my transformed function. So I'm just going to check when x is 2 by plugging into the actual formula. So this is going to be 2 times f of 1/2 times 2 minus 2 plus 2. So I just replaced the x in the formula with the x value of 2. I'm hoping that this is going to come out to 6 because that's what I got as my y value by transforming. So I'm just going to follow the order of operations here, and I get 2 times f of 1/2 times 0, which is 0, plus 2. And f of 0, how do I figure out what f of 0 is? How do I figure out what f of 0 is? Look at my original graph of f. Yeah. Here's my original graph of f up here. F of 0, that's when x is 0. What's my y coordinate? 2. So I can replace f of 0 here with a 2. So this says 2 times 2 plus 2, which is 6. So I got at least 1 point to match. You can always check a few points to make sure you did everything right. Or you can start by making a table and plot it. If you know, everything leaves your head, you can always make a table of values. All right, so on the next page of your packet, you have a transformation of graphs activity. This is activity 2. I want you to work on that until we'll say about 6:30, 6:35, and then we'll go into some review.